We are given the differential equation 1 minus cos x dy dx equals y sine x. And part A, we need to solve the differential equation, obtaining an expression for y in terms of x. This is a separable variable differential equation. So this y term, we have to move it to the left, and 1 minus cos x has to be on the right. So we divide throughout by y and 1 minus cos x, obtaining 1 over y dy dx equals sine x over 1 minus cos x. Integrating, we have 1 over y dy on the left, and on the right, we integrate sine x over 1 minus cos x with respect to x. On the left side, you just have ln of the absolute value of y. On the right, in order to integrate sine x over 1 minus cos x, we need to use the technique of substitution. So we let u to be 1 minus cos x. Then du dx is sine x, or du is sine x dx. Now on the left side here, we just integrate, because here sine x dx, that becomes du. So we have 1 over u du on the right, and on the left, we still integrate 1 over y with respect to y. Integrating both sides, we have ln of the absolute value of y. This is ln of the absolute value of u plus c. Now we replace u with 1 minus cos x, so that ln mod y equals ln of the modulus of 1 minus cos x plus constant of integration c. Let's look at this. The modulus of 1 minus cos x. 1 minus cos x is greater than or equals to 0, so we can lose the modulus. Then we have ln of the modulus of y equals ln of 1 minus cos x plus c. Taking anti-log, we have modulus of y equals e to the ln of 1 minus cos x plus c. And using law of exponents, we can write this as e to the c times e to the ln of 1 minus cos x. E to the ln of 1 minus cos x, that is just 1 minus cos x. And if we lose the modulus, then we have plus minus e to the c, which we can replace with a here. Then we have y equals a times 1 minus cos x. We are given the initial condition that when y is 4, x is pi. So we substitute y equals 4 and x equals pi into this differential equation to find the value of a. We have 4 equals a, 1 minus cos pi. Cos pi is negative 1, so we have 2a equals 4, or a equals 2. Then the solution that we want is y equals 2, 1 minus cos x. Part B, we need to sketch the graph of y against x. For x in between 0 and 2 pi, it does not include 0 and it does not include 2 pi. Otherwise, we are not going to have a solution. So let's look at B here. We expand this, and y here is 2 minus 2 cos x, which we can write as negative 2 cos x plus 2. So we know that the sinusoidal axis, the equation of the axis, is y equals to the last part here. And the amplitude is 2. The maximum value of the function is 2 plus 2, which is 4. The minimum value of the function is 2 units below the sinusoidal axis, which is 0. We have a negative cosine function. Let's say we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Minimum is 0. The sinusoidal axis is 2. So we can actually draw something like this, which we can just erase later on. Otherwise, you use the dotted lines and you should be fine. That is 2, that is 4. And we are drawing a graph that is a negative cosine function. So you start at the minimum, it goes pi over 2, we go to the sinusoidal axis, the maximum, the sinusoidal axis, and the minimum. So we can sketch the cosine function. And we use a hollow dot here because that hollow dot will indicate that x is in between 0 and 2 pi, excluding 0 and 2 pi.